Hello, this is our research and development project we're submitting for the CADSCOM. Our research and development project is error detection in software metrics using machine learning algorithms. This is from our client, Dr. Jim Salea, who is a professor at the University of Wisconsin-Eau Claire. Going into it, a little bit of background about it is that software testing is considered a very expensive process. Developers have to spend quite a bit of time not only finding the bugs, but then having to solve the bugs. And so, what our goal is to try to figure out the best places for where errors occur. Error detection with machine learning models will allow us to detect where in code errors are most likely to occur. This is going to be done through some of our research with our data. And so our question is, can machine learning solve this? Going into our first one, which is our models. The models we're using are two different models, the naive Bayes model and logistic regression model. Both of these are supervised classification models that we are planning to use in a binary situation where we are simply looking at if it does have bugs or if it does not have bugs, or if there's error detected or if there's no error detected. Moving on, we're going to move into the tools we're using. For the tools we're using, our scikit-learn Python library is going to be our main development tool we're using. The scikit-learn Python library has deep support around it and has implemented naive Bayes and logistic regression models. We're then going to use the scikit-learn metrics, which includes the confusion matrix, along with several other metrics to determine the performance of our models on our data sets. So now that we talked a little bit more about the tools, let's actually go into our data. The data we're using comes from an open source Java projects. These open source Java projects are real world projects from the Java Eclipse JDT core. All of our data is numerical data. This data is often going to be in a whole number, but sometimes it's just simply zeros and ones, as it is for the bugs or no bugs. We have a total of 14 columns, which means that we have 13 attributes, and then our one classification has bugs or does not have bugs, or is there an error detected or is there no error detected. This comes in a CSV file, and then we're going to use the multivariable analysis on it. Now we've talked a little bit about that, let's talk about our research and analysis. What we plan to get out of it? Well, with our machine learning models, we're running several metric tests on it. These metrics are our accuracy score, the F1 score, the ROC AUC score, our recall score, our precision, and our average precision scores. These scores are going to tell us how accurate our machine learning model is, which in turn allows us to determine if our machine learning model is giving us correct results and being able to predict the accuracy of when bugs or errors are detected or not detected. Finally, in our conclusion, we're applying machine learning to determine the likelihood of bugs or errors occurring in different things. So how well does machine learning detect errors? Our data, once more, is collected from several open source projects, and then this is being used to with our models to then predict when error detection will happen. This is the conclusion of our project, our research and development project, and I hope you have a good day. Thank you.